In November 2024, a 21-year-old engineer from Raichur survived a road accident, but her knee was shattered. Her brother had one request to Dr. Suraj Hindiskere at Sparsh Hospital in Bangalore, and that was she should be able to move and bend her knee with ease.
Okay, so there was this young 25-year-old lady who had a bad road traffic accident and she had an open trauma. She had lost most of her bone as a result of the accident. In fact, it was lost at the site of accident and she came with a very big open injury. So this of the clinical image look. So it was quite a bad, unfortunate injury. And then she was initial management was done. X-rays and CT scans were done. She was put on an external fixator. It was stabilized. The wound was washed, and it finally healed after a few weeks.
They could have easily fused the knee is a quick option, but she would have never been able to fold it. But 3D printing of bones has given doctors an edge. One of the advantages of patient-specific 3D bone is that the printed piece size is similar to the patient's original bone. There are no surprises at the operation table. Dr. Hindiskere sought the help of Kumar Sukrit, the medical design engineer at Sparsh Hospital, to print the 3D bone model.
So, to manage such a badly fractured area or the joint, doctor needed our help in proper visualization of the region of interest, like what all the fragments are there, what are fragments are missing, like some of the bone pieces unfortunately detached from the body onto the site of accident. So that's severe it was. So in order to have a proper visualization and assessment of the severity of the case, he wanted an anatomic model of the bone model, as well as some way of visualization into 3D as well. So we went ahead and got the segmentation done based on the CT scans which were performed for the patient immediately after getting admitted over here in Sparsh.
The team identified how much muscle was left behind, how much bone was lost, and the shape of the injured bone orientation. They also identified how much volume of bones was needed to reconstruct. While most of this identifying process is automated, an engineer needs to sit and fine-tune the properties in software for accuracy. Once the scanned image identifies bones, muscles, and necessary details for the surgery, the design is sent to the printer loaded with the material. In this case, it is flesh-friendly plastic. The process starts as a nozzle slowly prints layer by layer according to the design of the bone model. After finishing each layer, the nozzle repeats the same motion on top of the existing layer. This way, the print comes out in a three-dimensional form. In Dr. Hindiskere's words, 3D printing allows a surgeon to do the surgery before the surgery. It is not just doctors, but engineers are also in full in action to solve some of the healthcare challenges in printing life itself. That said, it is a challenging space.
So one of the broad aspects has been that the ecosystem for the entire thing hasn't really been mature yet. So the high-end infrastructure that would support it, the machine capabilities are still just coming in. They're still very expensive in nature. The expertise that is required is also still emerging. So there's a lot that is, I would say, to be done in the field. And also, I think while people are able to demonstrate the usefulness of it, I think it hasn't really gone in as a significant large opportunity per se in healthcare. So it is a combination of medtech. It's very exciting space, but I think it still has to emerge. But I would say that as we go forward using stem cell based tissues and stem cell based implants, this will be a major thing.
Despite the challenges, engineers are still pursuing the route toward the holy grail in 3D printing, that is, printing human organs. At Jayanagar in Bengaluru, an IIT Madras aerospace engineer, Surit Sundaram, founded his 3D printing biotech startup with 6 ambitious words. Macha, let us print human organs, he told his business partner Manish Amin just before they launched Avay Biosciences.
3D bioprinting actually is technology or tool which is used in the tissue engineering industry or tissue engineering space. the goal of humanity has always been to be able to artificially create, our organs and therefore tissues. And so what we're doing is we're developing sort of the equipment for enabling this.
In February 2022, the Ministry of Electronics and Information Technology unveiled the National Strategy for Additive Manufacturing Policy to increase India's share in global 3D printing to 5% within 3 years. Since then, the program has seen 42 startups. Outsiders are not allowed in the clean room at Avay Biosciences headquarters in Jayanagar, Bengaluru. This is where the liver cells sourced from cell banks in India are stored in liquid nitrogen. But before they start printing, biomedical engineer Priyanka Paul carefully mixes the liver cells to prepare bio-ink. First, the team sources the biomaterial from a private manufacturer. Then they design main concentration of biomaterial to print a 3D construct. When they mix the biomaterial and the cells, we get 3D bio-ink.
So for the 3D printing over here in Avay Biosciences, we use a pneumatic layer by layer extrusion method, where what we do is we take a particular concentration of material, of biomaterial or synthetic biopolymer, whichever desired, and then we prepare it in a sterile condition. Okay. Now, the sterility is very important to be maintained, is because if the sterility is not maintained, there are high chances of contamination in a 3D cell culture, which will actually drain the entire work which you have done. So once we have done the sterility testing by autoclaving or hot air oven, we prepare the biomaterial in a sterile condition. We maintain a standard cell population depending upon which palette in the bioprinter we want to get it printed up. And then we mix both the biomaterial and the cells population together with a sterile spatula. We don't use a stirrer because cells are already very fragile. If we use stirrer at a very high motion, it may disrupt the cells and cause apoptosis. So we mix both the cells and the bioink together and make the 3D bioink ready. There we load it into a loading syringe, which we connect it with a connector, and then we pass it into the extrusion syringe, maintaining the sterility throughout the process.
Before Paul presses the start button, she makes sure that the nozzle of the printer and the filament on which the print is to be made is aligned, the process of calibrating the printer. Calibration ensures the printing nozzle is in place so that the ink is put correctly in the area to be printed. The motion and the design of the nozzle depend upon the instruction given to the software using a technique known as slicing. Think of Google Maps. What slicing does to 3D printing is what Google Maps offers to someone who wants to go to a particular place. Slicing gives the printing nozzle directions on how it should move layer by layer periodically. Avay Biosciences wants to test the efficiency of various drugs used to treat liver failures. But to take the technology to the market, there are challenges.
Post-COVID, in terms of support from the government, from the Indian government, has been really good. Not as expected, but looking at the scale at which the biotech companies are coming up, are growing in India, I think the support has been decent, not just by BIRAC, but all the other departments like DBT, DST, Ministry of Electronics and IT, and whoever are supporting, the upcoming entrepreneurs and startup. With to, label few of the things, I feel in terms of capital, it has been decent. A lot of medical device and healthcare companies have benefited from, various grants given by BIRAC or DST. I feel the major challenge or something which these, government departments should look out for or should focus more on is, giving more support in terms of regulatory, so that these companies who are developing or doing research on maybe medical devices or formulations or whatever related to biotech, help them in translating it from a research stage to the market space. I think there's a big gap, and I have seen a lot of, medtech founders facing this issue where after a point where they have product ready, where they have done a clear study about where it fits, but still the acceptance from the other side, which is basically regulatory certifications, be it, clinical trials or the initial pilot projects, These are the stages where most of the early stage biotech companies are facing a lot of issues, and I think it's a major concern, and it should be addressed on a very immediate basis. And only agencies or only group of people who can actually push it and make it happen is and only the government. It should be state government. It should be the the concerned departments from the central government that should focus more on this rather than just giving out small capitals to startups. I don't think small check sizes are going to help that on the longer term. But there has to be continuous monitoring on who they are investing on. And there has to be an extended support from these agencies.
In India, corneal blindness is considered a common cause of blindness after 50 years of age. The only solution is a corneal transplant. But there is a massive mismatch of demand and supply, said Parinita Agarwal, a senior research scientist at Pandorum Technologies. The usual transplant is a daunting task, but the doctor has to stitch the corneal transplant onto the patient's eye. Vijay Chandru's team at Pandorum Technologies successfully tested 3D printed cornea made with biopolymer, hyaluronic acid, and gelatin. They have tested it on rabbits. It acquired the qualities of a regular cornea after the procedure. The printed cornea gets attached to the eye without a suture, and this is the catch because in this way, this technology bypasses another challenge in corneal transplant. The startup uses BioX extrusion-based printers and digital light processing technology, or better known as DLP technology, to print the cornea. They are yet to test the technology on humans and are waiting for phase 2 and 3 trials to be finished. One good thing about 3D printing cornea is that the space will never run out of bio-ink, said Agarwal at Pandorum Technologies. But 3D printing also puts the spotlight on the question, whose bone is it? Digital watermarks placed within 3D prints pose a challenge to the privacy of the individuals, said the authors Dr. Aniga Jones and Dr. James G.H. Griffin in the 2020 study published in the European Journal of Law and Technology, which calls for a regulatory body to provide guidance and support. In the study, the authors looked at empirical data related to the privacy of all sorts of 3D printed patient-specific models. In India, although the Medical Devices Rules 2017 under the Drugs and Cosmetics Act, DCA Act, do not specifically mention 3D printed medical devices, it can be applicable using interpretation, said Shivangi Roy, Deputy Coordinator at Center for Health and Equity, Law and Policy. But then, in computer-aided design, files such as digital patient records, one has to get help through the Digital Data Protection Act 2023 rules, which are yet to be implemented. Until these rules are in action, a consumer has to rely on Sensitive Data Protection or Information Rules 2011, which have similar provisions such as protecting present and past health records, sexual biometric data, and sexual orientation. Roy argued that there is no need for a separate section on 3D printed devices. However, 3D printed has increased the urgency of a robust data protection framework for patients. As policymakers untangle the ethical ramifications, doctors and researchers are celebrating small victories. The 21-year-old woman whose knee had to be reconstructed can now walk and even bend it to an extent. And her brother says the technology is changing lives. World over, researchers are trying to engineer human cells and tissues for this purpose. It holds the promise of revolutionizing medicine. 1. Donorless would be redundant. 2. Organ rejection would be a thing of the past. Doctors would simply take the patient's cells and print a brand new organ. It's not yet a reality, but it's no longer in the realm of sci-fi. You can read the full story on ThePrint. I am Ananthapathmanabhan. Thanks for watching.